Hello and welcome guys. Now in this tutorial we will be starting the very basic algorithm, that is linear regression. Okay, so let's get started. So first of all, linear regression is a supervised learning algorithm, and it is a statistical technique used to identify and model the relationship between two continuous variable, so a predictor or independent variable and a response or dependent variable. Okay, so the goal is to find a best fitted line that describe the relationship between the variables, so which is often represented by a linear equation, that is y equal to mx. Okay, however, unlike deterministic relationship where one variable can accurately predict the other, the relationship between the variable in linear regression is probabilistic, meaning that there is some degree of error involved. Okay, so the objective of linear regression is to minimize the sum of squared error between the predicted and actual value of the response variable, which is also known as residual sum of square. And this is achieved by finding the value of slope, which is m, and intercept, which is b. Okay, that minimize the sum of squared error. So the slope represent the change in the response variable for each unit change in the predictive variable, while the intercept represent the predicted value of the response variable when the predicted value is equal to 0. And more about slope and intercept in the later part of the video. Okay, so one more thing, that is the performance of linear regression model is often measured by coefficient of determination, also called as r squared, which represent the proportion of variation in the dependent variable that can be explained by independent variable. Okay, so a high r squared value indicate a strong relationship between the variable and good fit of model to the data. So the linear regression can apply to many real world scenarios, such as predicting how housing price based on square footage, estimating the amount of product sale based on advertising spend, or determining the relationship between a student study time and their exam performance. Okay, so consider a scenario, okay, where a company want to predict the price of their product based on their feature of the product, such as size, weight, material, and color. So they collect data from their previous sales and record the price of the product and the corresponding feature of the product. Uh, all of these are collected. They use this data as a training data to build a model that can predict the price of any new product based on its feature. Okay, so the model will generate a regression line, I will show you that later, that best fit the data point with the minimum error. Once the model is built, the company can use it to predict the price of any new product by providing its feature as an input. So the model will use the regression line to predict the price of new product with minimum error based on its feature. Also, error term we will learn in the coding part as well, how error term get reduced with the simplest example as possible. Okay, so the equation that you see here, y equal to mx, is a standard form of linear equation where m is the slope and b is and the line is b. Okay, that you see here, and y is intercept. I can show you here, but you can see here, right, a slope, intercept, okay, and this line. So I'll explain it in more detail. Okay, so which is a point where so the point that you see is the best fitted line. Okay, so the slope of the line refer to the steepness of angle of the line, while y-intercept represent the value of y where when x is 0. Okay, so however, some linear equation are written in standard form, which I mean integer coefficients such as ax plus by equal to c. So in order to use such equation easily with graphical calculator, they need to be converted into slope intercept form. Okay, so this involves solving the equation of y to obtain the y equal to mx plus b form, where m is the slope and b is the y-intercept. Okay, so you will see, I mean, reading forward, you will see, I mean, in so many articles, some of the equation written in this way. Okay. Okay, so by converting the linear equation to slope intercept form, it become easier to graph the equation and to analyze the relationship between the variables. So the slope and the y-intercept can provide valuable information about the behavior of the variables, such as whether they are positively or negatively related, and what their respective magnitude are. So the equation that you see here is a mathematical representation, okay, where y that you see here is is the dependent variable, or the variable that we want to predict. Okay, x1, x2 and xn are the independent variable, or the variable that we use to predict y. Okay, or you can say the feature of the columns. Then beta 0, beta 1, beta 2 and beta n. So these are the coefficient of the parameter of the model that we need to estimate. Okay, and the eta is the error term, or the difference between the predicted and the actual value of y. I hope this is clear. Now finding coefficient value that minimize the sum of squared error between the predicted and actual value of y is aim of linear regression. Okay, so this is accomplished by reducing the residual sum of squares, or called as RSS, using a method known as ordinary least square. Okay, so RSS equal to sigma of y minus y cap square, where y is the actual value, okay, that you see here. Y is the actual value of dependent variable. Okay, y cap is the predicted value of the dependent variable. Sigma is like sum of over all of the observation. Okay, now the second equation that you see here, x dash x whole bracket cap minus 1 into x dash y. Okay, so what this means, so x is the matrix of independent variable, x dash is the transpose of x, y is the vector of dependent variable, x dash x whole cap minus 1 is the inverse of the matrix product of x dash and x. Beta is the vector of coefficient. Okay, so don't get confused with these terms. These are basic equations. So once the coefficient is estimated, the linear regression model can be used to make prediction on the new data by plugging the values of independent variable into the formula. Okay, and solving the dependent variable by using this variable. Okay, so linear regression can be extended to multiple linear regression, where there are more than one independent variable to predict the dependent variable, that we will see in the later videos. Okay, now let's understand slope and intercept thoroughly. Okay, so in linear regression, the slope and intercept represent the parameter of the linear equation that describe the relationship between the independent variable x and dependent variable y. Okay, and the slope m that you see here, okay, or beta, according to the equation, so slope m is measure how much dependent variable changes a unit in the independent variable. Okay, for example, if the slope is 2, okay, so if the slope is 2, it means that for every 1 unit increase in x, y increases by 2 unit. The slope can be positive, negative or 0. Okay, so this is what slope does. Okay, and then comes the intercept. Okay, so the intercept b, okay, is the value of y when x is equal to 0. It represents the starting point of the regression line on the y-axis. Okay, so you can see that intercept here. Okay, so it's so this is a starting point for the intercept. Okay, so it basically either go upward, okay, this line basically, or go downward. Okay, and it basically change the line like this, first like this, like this, like this will keep changing until unless best fitted line is achieved. Okay, so this is how this slope and intercept changes value and keep rotating under the until unless the best fitted line is achieved. Okay, so the slope and intercept are very important in linear regression, because they help us to describe the relationship between the two variables and make prediction about uh, the dependent variable based on the independent variable. So for example, uh, if we have a simple linear equation of y equal to 2x plus 3, we can predict that if x is 5, uh, then y would be 13. Okay, how it will be 13? So we will put the values. Okay, we will put the values of x equal to 5 and we will get 13. Okay, so this is how this is how easy it is. Okay, it's not very confusing. Sometime equation can be confusing, but just ignore it, because we will be understanding thoroughly mathematically here. Okay, you don't have to go anywhere. Okay, so let me remove this. Now let's understand the error term and the regression line. Okay, so the error term is the difference between the actual observed value of a target variable and the predicted value by the model. Okay, so the error term is known as the residual, and it represents the part of variation in the data that cannot be explained by the independent variable included in the model. Okay, so the linear regression, the error term is calculated as a difference between predicted value of the dependent variable and the actual value. Okay, and it is used to evaluate the model performance, uh, and the goal of good model is to minimize the error term as or residual, which means that the predicted value are close as possible to the actual value. Okay, now the line that you see here is the regression line. Okay, so the in linear regression, the regression line represents the linear relationship between the independent variable x and the dependent variable y. Okay, x and y. Okay, so it is also called as line of best fit or fitted line. So the best fitted line is the line that minimizes the sum of squared error, that is vertical distance between each data point and the regression line. So it is calculated using the method called least square, which finds the line that provide the best balance between accurately fitted the data and by avoiding the overfitting, that is fitting the noise in the data. Okay, so the best fit line is the line that provide the best estimate of the relationship between the variable in the population from which the data is taken. Okay, so we will understand the error term and best fitted line with one example that I will show you in this video only. Okay, so now let's understand cost function, what it is doing here and what the use of this. Okay, so the cost function, also known as objective function or loss function, is a mathematical function that measure the difference between predicted value and the actual value in a machine learning model. So the goal of machine learning model is to minimize the difference of cost, okay, which is achieved through the process of optimization, like I discussed in the previous video also, optimization part. So in the context of linear regression, the cost function is typically sum of squared error between the predicted value and the actual value. So the goal of linear regression is to find the parameter slope or intercept that minimizes this error, which is achieved through method called ordinary least square, or you can say another method that is gradient descent. Okay, so by minimizing the cost function, the model is able to make more accurate prediction on unseen data. Okay, now you will ask me what is least square, what is gradient descent. Earlier we were only seeing least square method. Okay, so basically both, this least square method and the gradient descent can be used to find best fitted line in the linear regression. Okay, so the least square method is a mathematical approach to finding the best fit line. It involves minimizing the sum of squared error between the predicted and actual value of dependent variable. Okay, So the coefficient that minimize the sum of ones that define the best fitted line. The least square method has closed form solution, okay, which means that the solution can be found analytically without the need of iterative algorithm. Okay, on the other hand, gradient descent is an iterative optimization algorithm that can also be used to find the best fitted line. So in gradient descent, how it is different, the algorithm start with a initial guess of for the coefficient of the line and iteratively update the coefficient to minimize the error. Okay, and at each iteration the algorithm calculates the gradient of error with respect to coefficient and update the coefficient in the direction of negative gradient. Okay, and this process is repeated until convergence. Now both this method have their advantages and disadvantages. So the least square method is easy to interpret and has a closed form solution, but may not be suitable for large data set. On the other hand, gradient descent can handle large data set and it is more flexible, but may require more computational resources and careful tuning of learning rate parameter. Okay, so in practice, least square is more direct method to find the best fitted line, and it is commonly used in linear regression, whereas gradient descent is more commonly used in machine learning algorithm that involves more complex model and cost function. Now let's understand the working of gradient descent, how it works step by step. Okay, now the gradient we just learned that gradient descent is an optimization algorithm which is used to minimize the cost function in machine learning model. It works by updating the model parameter iteratively to find the optimal value that result in smaller possible cost. Okay, now so here let's understand step by step. So what we do is we first initialize the coefficient or weight with some random value, okay, the very first step. Then we calculate the cost function. So we will see this step in coding also, like we will solving two different types, one with simplest way and one with Python library that is already defined. Okay, so after initializing the coefficient with random value, we calculate the cost function for the current set of coefficient using training data. Okay, and after that we calculate the gradient. We calculate the gradient of partial derivative of the cost function with respect to each coefficient. Okay, and then we update the coefficient by subtracting a fraction which is learning rate of the gradient from the current value, and we repeat this step. Okay, we repeat this step to um, until the cost function converges or a maximum number of iteration is reached. So we need to define iteration also. Sometime what happens, it keep going on and it go in infinitely, and we need to stop at certain point, right? For that we need to set the iteration also. So in each iteration the coefficient is updated in the direction of steepest, like so first it will start from here, it will go up till here. Okay, this is the minimum point where it has to stop. Okay, and this is like a steepest, from top to bottom, like okay, steepest descent. This is also called steepest. Okay, so you initialize the random initial value here, okay, and you go in the direction of negative. Now it's also based on the learning rate. Okay, so I will tell you what will happen if you define large learning rate and a small learning rate. Okay, so in each iteration the coefficient are updated. So from here to here the coefficient will get updated again, from here to here coefficient will get updated. Okay, and this will keep going on, okay, towards the minimum of the cost function. So the learning rate determines the step size. So this is like a step size, okay, from one step to another step, where one of the parameter is step size, where you will see how it converge with small learning rate and high learning rate. Obviously with large learning rate it will converge faster, but there is huge disadvantages for using large learning rate. Okay, and the step size of the update need to be updated and chosen carefully to avoid overshooting. So what happens when we choose high learning rate, it overshoot. So let's say it start from here, it will directly overshoot here. See what happens when we take small learning rate. It don't overshoot, it go small, like the step size is small. And here if you choose the large learning rate, it will overshoot and the convergence will be slow. I mean, sometime it will come here, sometime it will come here, and it will jump within the part of the steepest. Okay, and we need to avoid that. Okay, so so the gradient descent updates the weight or the coefficient of linear regression equation in order to minimize the cost or error function. So the equation that is updated during the gradient descent is one that calculate the predicted value of the response variable y, given the predictor variable x, and the coefficient y, which is look like this, y equal to w0 plus w1 into x1 plus w2 into x2 and w dot dot wn into xn, where w naught is the intercept and w1, w2 and wn are the coefficient of the predictor variable, x1, x2, x3 are the actual variables. Okay, so the goal of gradient descent is to find the value of w naught, w1, w2, wn that minimizes the cost function. Okay, so let's understand this by one example. Okay, so let's say we have a data frame of bike weight that is in kg and the price in lakh. Okay, so this is the data point, and so for simplicity, let's for example, let's say our constant slope is 0.44. Okay, that you see here, 0.44, because we need some value to start, right? So it's like a random variable. Okay, like we have discussed in the gradient descent section, we need something to start on, right? So so that we can understand how gradient descent would optimize the intercept. Now the very first step will be to calculate the residual error. Okay, so you can see that how the residual error is calculated. So first of all, for each of the row you need to calculate the predicted variable. Okay, and you can see that the intercept is 0, slope is 0.44 into 150, that is the actual value, that is x. Okay, and it will give you the value 66. Okay, and same way you will be doing for all the rows. Okay, now like I told you, we need to calculate the residual error also. So we will fill the value and we will calculate the error for all of them. Okay, and this is what the value we will get. Okay, so and what we need to do next is we just need to replace the value of actual and predicted, I mean, which is a formula of squared error. We need to replace the value that is for all the row, for second row also, like this is how, I mean, first for the first row has been done, and if we do for second row it will come, and for the third row this will come. Okay, so hope you guys have understand how to find the squared error. Okay, and the value that we will get from here, it will be the error line that you see here, right? And that is it. Now next what we need to do is we need to calculate the derivatives. Okay, and the difference that you see here is the error. Okay, we need to reduce this thing only. Okay, so we will move the line towards where the point is actually okay, so now what we will do is we will find the derivative. Okay, so first of all, to find the derivative, what we need to do is we need to do the equation like del by del. This d is called as del in our term, so we'll put the del by del to the intercept, and this is how it will look. I mean this is intercept. Okay, old intercept. Now what we will do is we will do the derivative, and I mean all the value that however it is, it will be here only directly, and we'll find the derivative. So what we'll do, we'll apply the chain rule, okay, for each of the rows, and this is how it will look, and we'll find the derivative, and we'll add up. Okay, we'll add up. Okay, and since I have already done it, you can see the value what we have got is 461. Okay, So we need something to start on, right? For that only we have put the intercept to 0, that you can see in here. Okay, so you can see here I have taken 0 as the intercept for now, but in future part you will see that uh, it will get updated. First we need something to start on. Now this is the first derivative that we have found, and you can see in the next iteration it will get reduced and so on. Okay, now if you ask me how the 2 came here, so basically this is the 2 that is came here, so it basically come to the front, and if this value come to the front, subtraction is added to that number, and this is how the calculation has been done. Okay, rest of the number is same. You have your price and you have your bike, and this is how the value of came. 0.44 is the slope, 0 is the intercept. Okay, now coming to the next step, that is uh, calculating the step size. Okay, here the actual work of gradient descent will come. So gradient descent basically subtract the step size from the current value of intercept to get the new value of intercept. So the step size is calculated by uh, multiplying the derivative, which is 461. So here to a small number called let's take here a small number of learning rate, that is 0.1. Usually we take the value of learning rate to be 0.1 or 0.01 or 0.001, like this. Okay, so the value of step should not be too big, as it can skip the minimum point, and thus the optimization can fail for this case. Okay, large learning rate that you can see here. So it's like it is also called as a hyperparameter, and you need to experiment with it values. Okay, so when we will code, so we will see this thing also. Okay, so let's take our learning rate to be 0.01 for now. So our step size will become 4.61. Okay, and then we will calculate the new intercept, which is which we will get by subtracting old intercept minus step size, and we'll get minus 4.61. and then again we'll apply the same chain rule. We will apply it like what we have done back in here. Same thing we'll do. Okay, you can see here we have calculated the derivative with a new intercept. Okay, the only value that has been changed here is the intercept. Okay, and we'll calculate the same way, and same chain rule, and we'll get our new derivative, that is 4.33. Again we'll calculate the step size. Now it has become 4.33, and you can see that new intercept has been calculated, and it has came to minus 8.94. Now we have noticed that the value of step is high, okay, when the optimal solution is far away, and this value is less as we approach to optimal solution. Thus we can say that gradient descent takes a bigger step when away from the solution, and takes small step when nearer to the optimal solution. This is the reason why gradient descent is efficient and fast. Okay, so so we continue finding new intercept until the value of step trend to 0, less than 0.01. okay, or even in some case we predefine the number of steps that need to be taken. In practice this number can go to like 1000 or even greater, and thus greater descent uh, optimizes the slope and simultaneously in linear regression. And at last you can see that our derivative has come to 407, and you can see that it keep on decreasing. Okay, so first you will start with a random variable, calculate step size, you will calculate the new derivative, new intercept, come to again here, and this way it will continue. Okay, it will continue and come to here where the minimum is present. Now please note that only choose large learning rate when it is necessary, and make sure you practice that. I will show you in the coding section also how to go with correct learning rate, because something what happen is if you choose large learning rate, the convergence will be fast. The only disadvantage is when you choose small learning rate, the convergence will be slow, because you can see that you will move slowly. Okay, but if you choose large learning rate, you can you will sometime it will happen you never reach this point. Okay, so just wanted to keep thing on the mind. So this is how it. Okay, So you will start with some point and you will reach the minimum. Okay, and I mean you can see that how linear fit changed from what it was. You can see that it's changing, the the best fit line is changing. Okay, on increasing the epochs. Okay, epochs is like number of you know iteration need to be done, and this is how it basically looks visually. Okay, and the picture that I have shown here, the actual, this is how actual the previous best fitted line looks, but after doing all this thing, gradient descent, your best fit line will look like this. Okay, and you can see that error is very minimum here. Okay, very minimum. So this is how, I mean, the gradient descent works. So see you in the next tutorial. Next we will do some practicals in the coding part. Okay, so we will see a basic cost function. Okay, and then we'll see basic gradient descent using numpy library, and then we will go with the sklearn method. So we'll see all of them. Okay, yeah, hope you like this video. Thanks, and give a thumbs up.